Hello, everybody. Welcome
Hello.
to a new version of the Scaleway Sessions. This one is a special one, actually, because this is our first instance of Ask Dr. Cube, or Call Dr. Cube, or our Dr. Cube sessions.
We're
Uh,
workshopping it.
yeah, we are defining, or the name depends on what you think about it. The idea here is to invite an expert who will be our doctor who's opening practice within Scaleway Sessions. So I'm Diego, developer advocate here for Scaleway, joined by Eli, also developer advocate, and our first doctor, Arnold.
Yeah. Hello.
So do you want to introduce yourselves, folks?
Y-
Well, I'll go first. Diego did an excellent job of introducing me. I'm Eli. I am also a developer advocate. I am very much still in the learning stages about Kubernetes, but I'm going to do a lot of that today with our wonderful Arno, who is one of our solutions architects here at Scaleway.
Well, hello everybody. I'm Arno, a solution architect at Scaleway, like Eli just told us. I dressed up the part of Dr. Cube. I hope the next one will also take some time to have a lab coat. I'm not usually like this. I'm a certified Kubernetes administrator and I've been working with Kubernetes and container for 7 years now, and I will try my best to answer all your questions today about Kubernetes. I think Eli already has some question for me.
I do, yes. So we've been keeping an eye out from questions that we've seen out in the wild, ones that people have asked us. Um, so the first question I would like to ask you is what's the best practice for when you have a major update that you need to do to what's in your containers, the containers that you've deployed? So that could be like the OS update, or it could be sort of major software updates that you have developed. Um, if you want to roll those updates out without downtime across your cluster, what
Yeah.
sort of things should you consider?
So there are several levels to consider in this case. Kubernetes basically is a software by itself and is deployed on top of servers. So the first level you will need to take care of is the server, the very basic level. So server updates in Kubernetes should be done by adding more nodes up to date and then removing nodes by draining containers and making them move from older nodes to newer nodes. This way, you should not achieve downtime at all, and you will be able to make sure before moving the containers, the new nodes handle well with the Kubernetes version you are currently using. So that's for traditional Kubernetes clusters you handle yourself. When you are using cloud providers, either Scaleway or another one, most of the time the server version is managed by the cloud providers. And when they need to do an update, they will ask you to deploy new nodes pretty much the same way, using maybe a new pool of nodes and so on. And then you will have to move your containers from one node to another before removing the old nodes. So that's for the major version. For example, if you need to dist upgrade your Ubuntu from 20.04 to 22.04, this is the best way. This is basically the best way. Doing in place update of package is a good way of breaking things in the ways you didn't expect. So if you really are doing things on a production clusters with your whole application running and you don't want downtime, that's the way to go. Regarding containers, because I will leave Kubernetes for the last part. Regarding containers, use workloads. In Kubernetes, there are things called workloads. They are basically deployments, stateful sets, daemon sets, and so on. And when you are using workloads, especially deployments, there are things called a rolling update. That's one of the strategies. And when you are updating the deployment, It will start by deploying new containers, making sure they are ready. So be sure to have health check, ready check, and all those kind of probes. And when the new nodes, the new containers are ready, old ones will disappear. And those kind of rolling updates has also rollback features. It will be able to detect if too many nodes, too many containers does not start and roll back to an older version. It will be a simple command line and everything will go back to the previous version. So that's the best way to go for updating containers in a Kubernetes cluster. Now, updating Kubernetes. Updating Kubernetes is complicated. That's the worst part you have to update. You will basically start with your control plane. You will need to update several components. So your control plane should be composed of several nodes, master nodes, if you are doing things like KubeADM style. And you will update those nodes one at a time. And then all of the parts in Kubernetes should be able to still communicate when you are doing the master node update. Some versions are more compatible than others, so avoid skipping multiple versions. And
yeah,
then
your use of the word "should" there has
yes, that's the main problem, of course. And it will relate to one of the other questions I believe you already have about testing things in Kubernetes. Updating the control plane and all the master nodes should come first, and then you will be able to go on all your nodes and update the kubelet, so the Kubernetes agent, kind of like. That's why using managed Kubernetes sometimes easier. Because most CSP are able to handle updating the control plane and the various kubelets. You can also do so when you are using some deployment tool like Ansible. There is Ansible Kubernetes should be able to handle updates of the various nodes. Cops and so on should be able to do so. But much like in the old time with OpenStack, updating an orchestrator with the control plane is difficult and should be tested beforehand in an equivalent of your production. And if all goes well with Kubernetes, you should not experience downtime. Do it what everybody calls
You're getting
blue-green
testing. What does it mean?
No, I'm getting robot Arno as well.
All right, so we are getting another version of Arno. All right, human Arno's coming back. Yes.
Blue-green for upgrades.
Right.
Am I still there? Yeah, okay.
Yes.
You're a
We
little
got
bit
you back
muffled.
when on blue-green.
Blue
Can you
green,
tell us?
perfect.
Yeah. Can you explain what blue-green is, please?
Basically, when you were creating environments, you used to have development, staging, pre-production, and production. When you are doing blue-green, you have two production, pre-production environments equivalent. And when you are upgrading one, this one should become the production. And the old production becomes the new pre-production, and then you do the upgrade on this one. So you change your environments from blue to blue to green, and you keep always one environment completely separate from any tampering when you are doing an upgrade. Because if anything goes wrong,
You can just switch back over.
move
We lost him again.
Yeah.
Oh,
Place
Robot Arno wants to take over.
located be outside the cluster.
Yeah, that reminds me of some high availability systems I've worked on before at a telecoms provider, actually, where, yeah, you have two parallel versions running.
And do you only have two? Can you have four or a multiple of two? Or doesn't it make sense?
It's basically just since you are doing an exact equivalent of your production, that's a whole lot of hardware not doing anything when you are working on one platform. So most of the time, two is only needed, because if you have a production cluster with 200 nodes, that's 200 more nodes not doing anything when you are working on one environment. So it should be two. You can do more if you want.
Up to your wallet. Right. So you mentioned, yeah, maybe 200 nodes. And that brings me to another question that we have here.
Yep.
And it is, what's the best way for me to monitor a large number of clusters?
So larger number of clusters is different than the large number of nodes, of course. Main thing is centralized things. More like you have a command center, so which can be either done through software, specific software like, for example, Rancher. I know that GCP has Anthos. I believe AWS EKS everywhere, and these kind of things. There are open source software that can do these kind of things, where you have a command center, and from this command center you can deploy and manage all your clusters. So Rancher is a good example of an open source one. It's now part of SUSE. SUSE.
SUSE? Or SUSE?
SUSE. So
Yeah. It's weird.
in French, I just say SUSE, but well.
Don't worry. Every single episode we have had this discussion. The first one was Kube Cattle.
kubectl.
kubectl. Kube
How
control.
do you pronounce that? What
Kube
was
control.
last time? Last time was MySQL or MySQL.
MySQL. Yeah, of course.
So we will continue to have these discussions. Exactly.
Yeah. So basically, that's a way of managing all your cluster. But if your focus is only monitoring things, you can always use one central point with a Prometheus and Grafana, classical monitoring tools, and use remote write, because you can use a feature called remote write in Prometheus. When you install your Prometheus in an agent mode in your several clusters, and all your clusters will push the metrics they scrapes locally to a central clusters through remote write. And that's basically what we do when we are using a Scaleway Observability Cockpit. But you can completely do this your own way by installing a central server, central Kubernetes clusters, and push all your metrics in this one. You can also use, of course, paid solution like Datadog. It can be a good way also to centralize everything. So basically, centralize your data. That's my answer. If you have several clusters, use remote write, centralize the data and metrics.
So you mentioned there Scaleway's Cockpit, which is not yet generally available, I believe.
Yes, of course.
We have it in public beta now, or is it still closed?
I think it's still closed, but we give access rather easily. It's just you go to the beta page, inscribe there, and then we should give you access to the possibility to create a cockpit.
That's an observability tool, right? That's open source observability tool that we've been developing at Scaleway.
Yeah, it's basically a shared Prometheus with multi-tenancy. We aggregate a whole lot of data. all the Scaleway products will push their metrics into observability, and there is a Grafana associated, and you will be able to push your own metrics from your own application in there.
All
Yeah.
right.
We will have lots more noise to make about that when it becomes generally available. I'm personally very
of course.
excited for it. We actually have a question from the audience.
Yes,
Diego,
we
would you
do
like
have
to
a question, and you can see it there. Are you able to read that or not?
Yeah. In Capsule, which component is responsible for upgrading and restarting node? Is it open source? Identifying in an open source Scaleway Cloud Controller Managed repo. Upgrading and restarting node. So this part is not open sourced. It's Ansible script. It's developed by the Capsule DevOps. It's basically looking like, if you know a solution called Gardener. It feels like Gardener, but it's not Gardener. Gardener is a way, an open source project to deploy and manage Kubernetes clusters. And it feels like this, but there is the same philosophy, but it's our own development. Kind of like our own orchestrator for instances. It's basically based on QEMU for instances, but it's all Python and Ansible scripts on our end.
Awesome. Thank you for your question, Hail Slicer. Feel free to drop more.
Fantastic. Well, we can go on to more of the questions that I've pulled from across the internet.
Yeah, you're welcome.
Oh, explain namespaces to me. Like I'm 5 years old and I just learned what a computer is.
Yeah. So basically, do you know that a lot of people will maybe share the same first name? Basically, my name is Arnaud, but the president of Scaleway is also Arnaud. How can we differentiate two Arnauds? All the Arnauds, are they interchangeable? Is all the Arnaud exactly the same and all of them are clones? No, it is not. So basically, we have a family name. That's just another name in order to identify each Arnaud. So in a family, there should be only one Arnaud, because if there are several, we just attach junior, the second, and so on, in order to make sure we can identify a single resource, a single Arnaud. And that's what a namespace is for an object in Kubernetes. It's a family name. So basically, you can create a container, a pod, named Arnaud, and this pod can be created, for example, in your default namespace, or in my production namespace, or in my development namespace. It will be called Arnaud everywhere. But all of these are different containers. And that's what a namespace is. It's basically a way to separate resources. And it's a tool. It's a tool because basically when you create your application, you are not bothering about whether there are other containers with the same name. You create your application, you say, I have a front container, I have a back containers, and maybe I have a messaging containers. And when I deploy my application, I don't want to check if there is already a container with the same name. So I deploy my application to a different namespace, to my namespace, and this way I'm sure I am the only one in this with these names.
Cool. I mean, that makes it a lot clearer to me. Is it related to the ideas of like role-based access control within Kubernetes?
Yes. In fact, role-based access control in Kubernetes was added later on. It was not there at the very beginning of Kubernetes, but it's now part of Kubernetes out of the box for quite some times. And basically, when you create roles in Kubernetes, you either create roles for a namespace or cluster roles, which are roles applying to the whole clusters. And a role is a set of permission So maybe doing a list of all the pods, getting the pod, updating things, updating services, and so on, and accessing things. And you create roles specifically to a namespace or a set of namespace. And then when you create service accounts, you can add them to these roles, and these service accounts are in a namespace or not.
Right. So maybe as a junior developer working, like developing things that are going onto a cluster, I might not have access to a role which is able to do anything to production. I only have access to something that's going to allow me to do my job.
Yeah, basically, for most people, when you first started using Kubernetes, you got your first kube config, and this file is a file that define who you are when you are in the clusters, when you are doing actions. And this specific first kube config file, as a user, which is a cluster admin, which is a really heavy and powerful node, most like the root of your clusters. And most of the people use this file as is for as long as they want when they are doing things in the clusters. It's all fine when you're all alone in your Kubernetes clusters. If you are going to do multi-tenancy, you will need to create several accounts or service accounts and map them to a real outside users with, for example, a tool like OpenID and so on. In order to make sure that when you connect on your Kubernetes cluster, you are matched to a service account which has restricted permission and maybe is isolated in only its namespace and so on.
So are service accounts then correlating directly to roles?
Not directly. A service account is an object in Kubernetes. You will be able to add roles to a service account.
Okay.
And then roles are through an item that's called role binding.
Okay.
So basically, when you are syncing database, that's the small database that links two table, role bindings.
Right, and the OpenID hooking up of this whole thing is something that I need to develop myself, or
I actually know this. There's a plugin.
Yeah. In Kubernetes, there's a OIDC integration, and Scaleway offer it, and most of the cloud service provider offer it. And if you want to do it on your own Kubernetes clusters, like most of the thing in Kubernetes, it just things you add up on top of it. Kubernetes is like a giant Lego. At the very beginning, you have a few bricks, and it's looking very slick and simple. But if you want to add more functionality, and that's why Kubernetes is complicated, you can add a whole lot of things like operator, admission controller, new controller, cloud controller, and so on. All of these things are things that update your Kubernetes clusters, maybe, for example, through custom resource definition, CRDs. And that's the main difference when you are going from one Kubernetes to another. It's what are the plugins already installed. When you are doing your KubeADM Kubernetes at home, you have a very vanilla clusters. When you are installing distros like OpenShift, you have something that's very opinioid. There is an opinion. I will not try to pronounce this one in English.
Opinionated. Yep.
Yeah, this one.
A lot of syllables.
Yeah. So basically, migrating from one Kubernetes distro to another is just figuring out what you are going to miss in the other one.
I mean, a bit like migrating from one Linux distro to another, right? Like some software may not work as smoothly, or you may have to tinker around with something.
Yes, of course.
Or your headphones might not work. I've experienced that one myself.
Yes, most of the time in Linux, open source softwares are compiled and ready made as packages. But each distro has its own way of putting files in the file system and so on. So maybe when you are installing a software, you go from one Linux to another, and well, where does my nginx.conf files is? Why is it in nginx.d, or was it in modules.d, config.d? Where it is? So that's the main things you will have to look for when migrating from a Linux to another. When you are migrating from one Kubernetes to another, it's does this specific plugin is already installed? Is it Istio? Is it Linkerd for my service mesh? Is my ingress controller using a specific CRD or the out-of-the-box ingress tool? Should I learn about ingress routes and so on? That's the kind of things you will have to check.
We have another question from the audience.
Yeah.
From a security point of view, are the workspaces sufficient to isolate the workloads? You might have to explain to me what a workspace is.
Yeah. So basically, I think this person thought about namespaces instead of workspaces, because there's no notion of workspaces in
I'll feel
Kubernetes.
less bad about not knowing what it is then.
Yeah. And basically, if you just use namespaces and role-based access control, it will not be able enough to isolate workloads, because all the pods by default are able to communicate to each other through networks. So you just need to know what you are looking for, because if you add the namespace name to the container services name, you will be able to find a network route to your containers, or to your service. So to isolate these kind of things, you have to add network policies. Network policies are not available in all CNIs. So what is a CNI? A CNI in Kubernetes is the way all the pods will be able to speak through networks. There are plugins that can be added in Kubernetes to do network between containers. That's the very first one you have to add. Some cloud providers, some Kubernetes distro come with the CNI pre-installed. When you are doing your first kubeadm install, there is no CNI. You have to choose one. And there are several usage suspects. So there is Cilium, Calico, Flannel, Weave, and so on. That's the CNI. Some CNI don't allow network isolation. And if you don't, because they are the very first one. Flannel, for example. Flannel is very easy. That's the very first CNI you will learn about. And Flannel does not offer network isolation. So you will have to install things like either Cilium or Calico and so on. And you will be able to create a new item called network policy. And these policies allow to check which namespace can go to which namespace. And if you want to make very sure everything is all right on top of this, you can add another tool called Open Policy Agent. So that's something that is going to be checking that when you create a resources, it satisfies a set of rules. For example, you will not be able to create a container with escalation privileges. Because if you for very basically in a Kubernetes clusters, like in Docker, you can mount any resources from the hosts. So you can go on the host as a root. And if you can do that, you can do anything. So multi-tenancy through namespace, if you allow these kind of things, it's not security. So you have to avoid people escalating privileges, accessing things on the host, accessing networks. So from my point of view, multi-tenancy in Kubernetes is complicated. It's doable. there are hardening guides for Kubernetes available on the web. Read a lot about that before trying multi-tenancy in Kubernetes.
Great. Thank you for your questions. Enki__. And then we have another question. Oh, great. I put it on screen. So, in Kubernetes, there is a race condition on pod deletion between kube proxy, routing, update, and pod exits. How do you gracefully shut down pods without dropping traffic? Example, on routing upgrade. A pre-stop hook with an artificial delay seems not sorry. A pre-stop hook with an artificial delay seems not optimal to solve this problem.
Yeah. So this one is complicated.
Good.
Yeah, very complicated. It's a good one. Basically, you will have to add on top of your application something that can cache and wait for the backends to be available. So some ingress controller, from the top of my head, I have to check which one allow this kind of things. But you will have to have a front able to check if the backend is up and running and ready to respond before answering and avoiding a drop. And the important thing also is making sure you have the readiness probe, because this way you will not forward traffic to pods that are not ready, of course. And then if you don't cache questions before, that's an interesting question. I may not be able to answer this one as it is.
That will be fine. We can come back to this. I mean, you will be definitely invited to be our doctor in a future release. We could create content around this question.
Right? If you can, of course. If you can just copy paste this question somewhere, I will be able to try and find an answer, a better answer later on.
Absolutely.
I mean, it reminds me of a question that it was on my mind while we were talking about rolling updates, essentially. When you are in the middle of that update, are there strange states that your cluster can get into where maybe a request comes in and it gets routed to one pod and then that one's updated and then another one isn't, and you have this mismatch? And I think this question is sort of getting at the same sort of, the middle of an update is a strange state for a cluster to be in.
Yeah, of course. So that's basically the developer problem, really. In this kind of case, and that's something that happened a lot more now that we have rolling updates. And for example, there is also canary testing. When you forward only a part of your traffic to the new application version. For example, you only send 10% of your traffic to your new version, and you still keep 90% traffic to your current version.
Like A/B testing updates to a developer tool or something.
Yeah, of course. And that's something that's complicated. I'm not a developer on myself because I'm mostly a sysadmin. To be completely honest, I'm a chemist. I'm not in IT. I've been lying all these years. So developing new application, cloud-ready application, because that's what is all about. Cloud-ready application are able to handle calls because they are doing all the things by having microservices and using loose coupling. So basically, an application does not check what is, does not need a specific version of somebody on the other end. It will talk its version to the application on the other end, and the other end is supposed to be able to handle both version, new one and old one, and then you deprecate at one point the older version of the API and on the other code and so on, and you make sure everything is all right. So that's difficult for the web part, but it's really doable in fact. But what is really difficult is when you are doing this for databases.
We have a lot of questions about databases because yeah, that's where it gets really hairy, as I understand it.
Yes, because when you have multiple versions in databases and you do version control in databases, you will be able to apply a file to update your version. So it will do all the SQL queries about updating and rolling all the alter column and so on you will need to do. But at one point, your application is going to try and speak with these databases at the very end, because most of the part of the app are going to speak or to the different parts using API. So it will be gRPC and so on, REST and etc. etc. But in the end, there is one part of the application that is going to speak to the database and will need to find specific info in the database, and this part is the hard part, and it will need to not do a running update on this one.
Is that the part where you might experience downtime? Because
that's the part when you might experience downtime. Maybe you will need to do a dump of the database, create a new one, update this one, add on top of it a container, and then switch from one container to the other by maybe changing the services, because in Kubernetes, exposing a container is done through services. So you can have multiple containers pointing to different databases, and you can switch the service if you need. You can go all this way if you are updating things in a database, and it's a heavy update, of course.
But in between the time when you've taken the dump of the old database and you stood up a new one with the same data, what if there were things that had written to that database in that interim? Will you lose those changes? Will you just sort of apply those after, Is that also
there is always a small time, so automate things. Of course, it will be faster, and this way you will not lose as many operation. You can always switch the database in read-only mode for a few seconds before log transition and so on. And there's many things you can do. You can also redo transaction from the old one to the new one. All these kind of things to synchronize the database later on.
And of course, from a user's point of view, scheduled downtime is always better than unscheduled downtime.
Yeah, of course.
Great. We got into a real interesting conversation from one single question from Health Slicer. So yeah, please keep an eye on our socials.
And please, Diego, make sure I will keep this question for later.
Yes, we will answer it somehow. So keep an eye on our socials, Scaleway_devs, and of course our Scaleway community over Slack that you can find in the link that was just shared over the chat in Twitch, and I will also share it on YouTube because why not?
Yes, I mean, Health Slicer, I am guessing that you're a member of Scaleway community, having asked a question about Capsule. Please drop your questions in the Slack so that they will persist, and we will definitely have access to them. And if you have any more, keep them coming.
Oh yeah, please do.
So I'm ready for the next question.
All right.
There's one that I'm interested in, and this is actually a question from me. Are there testing techniques which are specific to Kubernetes? Are there failure modes of software that Kubernetes introduces that are unique to this style of deployment? When we've talked about the need for sort of hard cutover of databases, but that's also something that's true in other methods of deployment.
So basically, what's true for container is true for Kubernetes. When you are running your application in a container, you are not running in a real OS. It's not a VM. You will not find everything. Some things may happen working, but they are not. And anybody trying to mount a Fuse FS in a container realize pretty quickly a container is not a lightweight VM. So when you are maybe doing your containerization of your application, you will need to make sure your application and your engine start correctly and is ready, and there is no strange error message or logs or warnings that may happen specifically to containers. So that's why developing and testing directly in the container is a good idea. Developing on a VM your application and then say, well, I just do the same thing in a container, it will work. Bad idea.
Well, that's
Bad
one of the
idea.
problems containers are meant to solve, right? They're like, it works on my machine. Well,
Yeah.
yes, you have all sorts of libraries installed or, low-level tools or...
Yeah, of course.
Yeah.
So it works in my containers, not in my machine. If it works in my containers, it should work in yours. That's okay. This one is okay. If it works in my VM and I just did the same thing in a container and I just run it, not a good idea. It may not work this way.
Yeah.
You will have to test it in a containers. And then basically in Kubernetes, what you will need to check, maybe name resolution, these kind of things, because everything is handled by Kubernetes through core DNS, for example. And when you are trying to access the outside world or the other containers, that's core DNS that's answering. That's not the default DNS that was in the container. So maybe when you are doing things in your Docker and local Docker and it works, and maybe even in your Docker Compose it works, and when you push it in Kubernetes clusters, it may not work anymore. Because maybe the core DNS is not currently referencing the same DNS, or maybe there is some specific values in your Kubernetes clusters. Most of the Kubernetes clusters are deployed the same way with a service svc.cluster.local and these kind of things, but maybe it's not the same in the end. So make sure you test name resolution in Kubernetes.
Are there sort of automated ways of testing that, or would it be manual testing every time?
No. There is a way through, for example, init containers in Kubernetes. Those are fencing. It's a small container that started before the real containers. It will run a script, and then if everything went well, it will give the end to the real container. And you can add init containers which do some testing and checking and so on before the real containers. And if the init container fails, the real containers does not start. And so if you are doing a running update, it will may mark as failed and crashing and so on, and it will trigger the rollback.
Right. Cool.
So maybe do it this way. I think there is multiple way to do this kind of testing. Basically, having a pre-production and testing on the pre-production before going to production is a good idea to test these kind of things. But testing within a container can be done also. I don't know if it would be the best practice, but it's completely possible and feasible this way.
Good. Now, before we jump into the next question, I would like to ask you about what I'm assuming is your home lab. So all the hardware behind you. Right?
Yeah.
So what can you tell us about your setup?
It's power off most of the time because it's very, very noisy. Those are 3 servers.
Like real servers.
Yes, they are real servers.
Yeah.
This one is just a classical switch. There's 3 servers, one U, and just a laptop which is managing everything.
You were
afterward.
not kidding when you said you're a sysadmin. That is one of the most sysadmin things I've ever seen. Is real server rats in your house.
Yeah, they are only powered on if I really need to install and test hardware things, basically Proxmox or maybe OpenStack or VMware and so on. So most of the
Right.
things are does not do anymore at Scaleway.
But it's interesting. It's interesting to know that you still have your own hardware to test things with. And that
Yeah.
leads me to the other question that I usually ask our guests is, how do you recommend us start with Kubernetes? How should we start learning Kubernetes? We
Okay.
probably don't have a big resource like your 3 servers behind you, or if
Yeah, of
we
course.
do, maybe we don't have the money to pay for electricity for all of them.
Yeah.
So is there a way that we can start like in our local machines or with our small home labs?
So there is multiple way to start learning Kubernetes. For example, there is something called Kind, which is Kubernetes in Docker. Which is a small tool you can install on your computer together with Docker, of course, to start several containers which will act like a Kubernetes clusters. So it will be a more like local Kubernetes. You can do also K3S, which is a lightweight version of Kubernetes, which was deployed by Rancher and is now completely open sources and sourced and gave to the Cloud Native Foundation. And you can also just let me take 1 second off screen.
No worries.
Yeah, I'm very much getting to the stage where I have learned
What
a
is
lot of
that?
Kubernetes concepts, but I'd like to get my teeth into
You
it.
have a pile of money.
Yeah, basically that's a Raspberry Pi.
One of the most
This this is
precious
a
items nowadays.
small hat that's added on my Raspberry Pi, and all of these are Raspberry Pi Zero. And
Oh,
so all
zeros.
of zeros, yes. So all of these are a cluster, and you can install and manage a very small Kubernetes, but hardware-like Kubernetes. So this one works too if you really want to learn Kubernetes.
Amazing.
Maybe
And
I'll
you can actually get Pi zeros more easily than a regular Pi A or B.
Yeah.
maybe I'll use that to host my own personal website that's just HTML, CSS. So it's got no very lightweight.
Yeah, it will be. It will be funny. I don't know. It will be efficient, but it's possible. It's possible.
Yeah, one of the things we've sort of kept coming back to talking about Kubernetes is that it's a tool that's designed to solve big, complicated problems
Yep.
of high availability and scalability and ease of deployment,
Hmm.
and that there aren't a lot of sort of hobby projects
Yeah.
that have those same needs. And so finding a project where you're using Kubernetes to solve your own problem
Hmm.
as a hobbyist is actually quite difficult. And that's my go-to method for learning a new technology is, well, find a problem that I want to solve and use this thing to solve it.
Yeah, of course.
Yeah.
And just for sake of completion, there is also something called micro Kubernetes.
I've heard about this as well. I've heard
Yeah.
mini
Right.
Kube as well.
Yes, Minikube also, but I'm not a fan of Minikube because basically it's going to deploy a VM through VirtualBox and install everything on this VM. And I'm not a huge fan of VirtualBox because, well, it's open source, yes, and it works well, but there is a lot of clutter with VirtualBox. If I really want a VM, I will go straight for libvirt and QEMU and go real hardware mode.
Sure.
Mm.
The hard way.
Yeah.
Yeah.
I've used VirtualBox before, I think at my first job out of university, but that was just, the company said, use this for your VMs. So
Yeah.
was not a choice on my part. And I was certainly not educated enough at the time to make such a choice. So
We should at
Yeah,
some
and
point.
it can be complicated. VirtualBox allow use. It's easy to use because it's very UI like, and you will find all the click beginners love and adore like I used to. Now I'm more a command line person. I still use VI to develop, and only VI.
that is sysadmin, sort of, you're on brand there. Yeah.
Yeah, completely. And I will not start an Emacs versus VI war. Not now.
That's great. We should at some point have a chat about QEMU, especially because we will have a discussion about the naming. Is it QEMU, KEMU,
Oh no, it's another one we
KEMU?
don't know how to pronounce.
Yeah, it's
Yeah.
basically emulation. So QEMU, but well,
Yeah.
yeah,
Brilliant.
and since that's basically the Linux way, the most basic Linux way to have a VM, because it's completely integrated with the kernel. It's using KVM and so on. So, and that's what we use for all our instances here at Scaleway. So, and that's what also behind the scene VirtualBox use, I believe. That's what OpenStack use also. So that's something that's basically a big piece of Linux software.
Right. So I got another question, kind of related again to what you just showed us, actually, and it's your actual edge devices, the devices that you have at home. What if you wanted to make those part of your whole cluster that is running in a cloud provider?
Yeah. So, of course, there is a way to connect this real hardware to internet. Basically, you will need to have a good internet provider. If you are using these things at home, you will need most of the time to have a fixed IP address. You will need to do all the network address translation.
Right.
Because this machine will have an IP in your home, and your box will need to expose this various machine.
All right.
And then if you want to pilot this machine from a cloud provider, you will need to install an agent on this machine. It will be either a push or pull way of doing things. So either your software in the cloud will be just waiting waiting with a pile of tasks, and the machine will connect to the server. So, for example, a web API or a messaging tool and so on, and pull tasks to do here, and then execute all these tasks and then send back what they did. Or they will receive order from the command and center. So that's the way I will architecture this kind of things. You can also use a VPN, basically. That's the most basic things. You just install in VPN endpoint and in the cloud, and you make them part of the same networks, and they will communicate this way. So that may be a way to make this hardware part of something in the cloud. And of course, if you are thinking Kubernetes, there is a way to do so using a specific CNI called Kilo, which is an open source CNI, which use WireGuard, which is an open source VPN, Linux VPN, very popular. Yeah. It's not part of the kernel of Linux. And guess what? And I believe that may have been the end goal of the question. Here at Scaleway, we have things called Cosmos. And Cosmos is a brand of capsule, so a brand of Kubernetes, managed Kubernetes by Scaleway, which is using Kilo out of the box, and we all handle the addition of the nodes. You only need to expose them on the internet one way or another. So, like I said, network address translation or this kind of things. And when it's exposed on the internet, you will be able to install on this server Ubuntu, and then run a shell script. And this shell script will connect to your Cosmos, do all the configurations such as installing Kubernetes, containerd, and so on, and creating the VPN connection between your hardware and the Cosmos control plane. And all the nodes will be meshed using WireGuard,
Right.
and will behave as if they were in the same networks. So
it needs to be something large enough to have Ubuntu on it. I couldn't do this with like my Raspberry Pico Ws, my Raspberry Pi Pico Ws, which are tiny. They have like micro.
Yeah, it may be too small to be able to run this kind of thing, but a small embedded things may be able to run a classical version of Ubuntu. I will have to check if our script is compatible with ARM architecture, because I don't think that's the case for now. But since we are just started having ARM instances, started again to have ARM instances at Scaleway, maybe I will do the test and try to add one in Cosmos.
That's another interesting topic for us to cover in the future.
Yep.
But I must say that the question didn't have any angle, but it's good that you could connect it with something that is kind of real and people can try out.
Yeah. Well, I wanted really to not just say and do marketing stuff and say we have a solution for everything. Let's be real. When you are doing LOL Slicer, have a nice weekend. When you are doing IT, there is a whole lot of solution to a single problem. And if you are too used to use a hammer, everything looks like a nail. So maybe take a step back, think again. Maybe sometimes a simpler solution is possible. And if you have a screwdriver, maybe do not hammer screw.
Awesome. Have we run through all of our questions? Oh, there's one more that could be potentially quite a big topic.
Yeah.
Essentially security? What are the main attack vectors when it comes to a generic Kubernetes deployment? Sort of what are the security concerns, and what are the sort of different things that we can do to mitigate risks when deploying a cluster?
Yeah. So basically, like I previously said, one of the attack vectors is basically gaining access to a container and escaping the container. And that's the basic one. If you are using open policy agents and open policies to make sure your containers does not allow privilege escalation, if you drop Linux privileges and make sure you are using rootless containers, you should be fine. And my best advice is use hardening guide for Kubernetes.
Okay.
If you are using your own Kubernetes. Then attack vectors are basically trying to hammer every endpoint of the nodes and see what is open. And that's why here at Scaleway we are going to beta test very soon a feature which was asked many times again, is a way to connect your Kubernetes nodes to private networks and don't expose your node anymore to internet. That's going to arrive very soon. I believe the beta is going to start just at the beginning of April. It should start the 3rd of April. Maybe
soon.
sooner.
Yeah.
Maybe sooner if we are able to do so. It will be for the beginning a private beta, but it will last 1 month. So it'll be open to public very soon.
Sounds quite useful.
Yeah, of course. And another attack vector is accessing the API through the cluster admin role. So make sure not to use your kubeconfig file everywhere and left it somewhere. You should not be. Use list privilege role when accessing your cluster.
Something that confused me when I was first sort of learning about Kubernetes, and I started out by learning about how to authenticate users, so how to let people administer various parts of your cluster, and obviously then you get into role-based access control as well. But the idea of bootstrap tokens, which are, as I understand it, tokens that sort of exist at the beginning of a cluster's lifecycle, and they don't expire, and they have a lot of privileges. The bearer tokens. How should you handle those? Should you use? I think you have to use them. I think, or at least Kube admin, like Kube ADM, uses them. Are there risks associated with those? How should you use those responsibly?
So certificate rotation, certificate expiry, and so on in Kubernetes is a subject. It's a real subject, and there are best practices about all of these certificates. Kubernetes is supposed to rotate some of those certificates by itself. Some of those should be rotated manually, or you have to trigger the rotation. And the time duration of this certificate should be not too long, in order not to expose security between the communication. And avoid also leakage of token or certificate that allow authentication. Basically, doing all of this by yourself is complicated. That's why using an IAM tool, like for example free IPA or these kind of things, or Keycloak, for example, is a good idea, because you will be able to manage your user externally. You will be able to map automatically using OpenID things with your users, and you will be able to expire users and make sure in the Keycloak part, and make sure that yes, you will close access later on.
And if you don't want to host your own Keycloak, I happen to know that there is a company called Cloud IAM, also French, who do a lot of really great work around. They do hosted Keycloak, and they also do a lot of great security work, enabling people to have easier access to these kind of tools.
Yeah, completely. They are basically doing Keycloak as a service, but in very smart way. I have been working for a time with Cloud IAM as their solution architect.
I didn't realize that was you as well. Yeah, awesome.
Yeah, and basically I did not have a lot of work to do, because they know a lot of things already about how to do things at Scaleway, and I was just answering very specific technical questions about that, and it was very fun.
Yeah, I've had the privilege of speaking with them as well, and they're clearly very intelligent people doing really interesting work. So this is not meant to be a Cloud IAM marketing stream. I just really like them. Awesome. Yeah, no, that's a really good answer about sort of security concerns. Something that I'm very interested in, because as soon as I see a piece of technology, I want to know how it's going to break. So
yeah, of course. I believe there was a question, because I read a question about UI in Kubernetes.
Oh, yes. Are there UI tools that you like for sort of visualizing and monitoring a cluster? I came across this because there was a Reddit thread mentioning something called KUI, and then there's also something called OpenLens, which I know is popular.
Yeah.
Do you have opinions on these sort of recommendations?
Yeah. So basically, I hate KUI because it's very rigid. I don't like because
Okay.
it will not work well with custom resources. When you are connecting to some managed clusters, it tends to be messy in some parts. It feels like Jupyter notebooks, and I don't like Jupyter notebooks. So basically, I'm not a fan of KUI. I haven't tried OpenLens because I was not aware of OpenLens. I only knew Lens, which is a subscription tool. There is a personal licenses. I think it's a free licenses to handle, but I'm not a fan of not uh, of giving admin access to something that is not managed by myself.
Understandable.
Uh, yeah, so I used to use a lot Kubernetes.
Yes, that
Uh,
was mentioned in the
yes,
thread as well.
but it's a TUI, so text UI. So it's very gratifying for nerds like me because it feels like you're looking at the matrix and so on, and that's great. But if you want an UI, you can try also installing things in your Kubernetes clusters. So the basic one is a Kubernetes dashboard. So that's the one Scaleway provide by default. That's one you can install also. But it's a bit, there's not a lot of features in this one. If you are looking for features, there is an actor about UI and containers that have been here for quite some time called Partner. So Partner was a UI that was basically a way to handle your Docker Swarm at the very beginning. You install it in your cluster, you connect on a specific port, and you will be able to access everything and modify things and so on. Docker Swarm kinda lost the war in the orchestration of container things. But it's still there, but it's not as much popular as Kubernetes and Nomad. So Partner evolved and is now able to handle Kubernetes clusters and Nomad clusters normally. I did try for Kubernetes clusters, not for Nomad clusters yet. But Partner is a good fit also. And if you
Great.
want to go just a step above, you can also try Rancher. Rancher from Suze, like we told
Yeah.
earlier, is a way to administrate your local cluster and administrate remote clusters also.
This is
Awesome.
great. I had tried a Portainer in the past in my local Proxmox. It was
Ah.
great, but I didn't know that it could handle Kubernetes as well. So
If you
I'll
want to
give
Yeah,
know
it a
more
try.
about Portainer, I'm actually going to be doing a podcast in a couple of weeks with David Flanagan of Raw Code Academy. And on that podcast, as well as me, will be Neil Cresswell, who's the CEO of Portainer. I'm very excited to be on that and learn more as well. Um, yeah.
Awesome. We'll
Yeah.
be
So good.
sharing
Oh, that'll
some
be on all
links
our
to that.
socials.
Yeah.
Yeah. I won't shut up
yeah,
about it. Don't worry.
Amazing. I think that's all of the questions we had for today.
yeah.
And we covered that in, yeah, basically an hour. It's great.
My brain feels very full of new
Oh,
things.
yeah.
Yeah,
To go away and
Oh,
let
yeah.
it percolate.
you will get more brain ache when you will read my future article about gradiating from Docker to Kubernetes.
Excellent. Can't wait.
Yeah, yeah,
Amazing. Yeah, we'll be sharing that on our socials as well. So thank you. Thanks a lot, Arnaud. You were our first doctor, and we
yeah.
can have a better
And I hope the
experience.
next doctor will also wear a lab coat
Oh, well,
and
They,
glasses.
see if we can get one a Scaleway lab coat, like nice and
we,
Yeah,
we
maybe,
have to. I mean,
but
you
it will
started
be
a
it will
trend,
it will need to be bigger than this one because like I said, it's from my daughter, so bit.
but you have some kudos here for your uh, outfit over here.
Yeah,
So yeah, again, thank you so much for sharing with us, for teaching all of these different topics around Kubernetes to all of us. I know I learned a lot, And my brain, yeah, as Eli says, is full of knowledge. I need to just use the weekend to let that sit in and maybe
Yeah.
try out Portainer one more time and Rancher. Why not?
Yeah.
Maybe connect my Raspberry Pis to a cloud provider, because why not?
Yeah.
Hey, I
Yes, why
mean,
not?
we've got
Yeah.
Cosmos right there.
Yeah.
Exactly.
Or if you just want to do Internet of Things, we also have an IoT hub. So just install MQTT linked on your Raspberry Pi and start sending small info to your hub, and you will be able to route these to a database, an S3, or just do a webhook with a serverless function, for example.
That's yet another session that we need to have.
Get text
Definitely.
sent to my phone when my Raspberry Pi detects that my plants need watering or something.
Yeah, of course.
There's like kits for that, I'm pretty sure. But yeah,
Yep.
awesome. Maybe I'll do it with Kubernetes.
Perfect.
Why not? Thank you so much for being here. Thank you to our audience. Thank you, Eli.
Well, and
We'll
thank you, Diego, who is the mastermind behind these streams and runs them.
Yeah.
Yes,
Thank you.
And thanks for inviting me.
Of course,
it's
you
been
will
a
be
delight.
here soon, I hope, with
Yeah.
an official Dr. Kube robe.
Yeah.
But
Perfect.
until that time, well, we'll see all of you, our dear audience, next Friday on our next Scaleway session.
Yes, and
Have a
we've got
great
some
weekend.
exciting guests for that one as well.
Oh, yeah. Wait for more news. Have a great weekend, and we'll see you soon. Bye-bye.
Thank you. Bye bye.